Hello and welcome to the Key Concepts lecture for Philosophy of Psychology. We're now in week 11. We're going to be looking at the subject of rationality, which has been quite a controversial topic in recent years, with philosophers and psychologists kind of chiming in with different perspectives and different sort of views of what rationality is and how we should think about it and how it works. So we're going to pick apart some of these ideas in this lecture and look at the research by Kahneman and Tversky, the well-known heuristics and biases program. And we're going to look at some responses to that research as well in this lecture. So we're familiar with this idea of humans as the rational animal. And of course, this goes back to the ancient world and the Aristotelian view, Aristotle's view, and its influence on Western thinkers. That the thing that sort of distinguishes humans is this sort of possession of rationality. And when we talk about humans being the rational animal, it's a little bit different to the idea we're talking about. Certainly in this chapter of the textbook, and what Kahneman and Tversky are talking about of humans as logical rule followers. The idea of being a rational animal just means that we're amenable to rationality, and our actions can be sort of judged according to how well they adhere to or deviate from what we would regard as sort of meaningful and consequential and sort of logically entailed behavior. So as the rational animal, we can, it's compatible with that we make mistakes, that we kind of overcome occasionally with emotion, perhaps, but we don't sort of lose our status as the rational animal because of those things. Whereas the assumption seems to be that in sort of making mistakes in following logical rules, the assumption is that we are thereby sort of less than fully rational. So it's important to distinguish these two uses of rational in terms of us as the rational animal, which is a kind of broad sense of rational and is compatible with sort of mistakes and errors and sort of getting things wrong. Versus this idea of humans as logical rule followers, where the failure to follow the logical rules seems to be a problem of deficient rationality. So this is really the standard picture of rationality in psychology, where it's come to be upheld that reasoning in accordance with the rules of logic, probability, and decision-making is rational thinking. So it's too stringent to say people will never make mistakes. The idea is that they should not make systematic reasoning mistakes. And that's what the heuristics and biases program was really supposed to kind of unearth. Is it true that we make these kind of systematic mistakes in reasoning that sort of that suggest that we're not fully logical? As we'll see, not everyone agrees with this picture of rationality as a kind of logical know-how. We might also take up the issue of competence versus performance. Some might argue that people are competent to apply the rules of rationality, but can sometimes make mistakes in performance. And in fact, philosophers have endorsed this view, some philosophers, but that does not affect our ascription of rationality to people who sometimes make mistakes in performance. It's just, we're not perfect, and we sometimes get things wrong because of features of the environment, mistaken information, whatever. So we've got to see if there are these systematic reasoning mistakes, and whether the argument holds that's what's going on in these kind of, that's being unearthed by the heuristics and biases program, and that's what we're seeing in these examples. So with that, let's turn to look at some of the examples from the heuristics and biases program. So this is what's called the Wason selection task. And there are four cards. There's a card with an E, sometimes an A, a vowel, a K, a consonant, and an even number of 4 and an odd number, number 7. And participants are asked to test this rule. If a card has a vowel on it, if a card has a vowel on one side, then it has an even number on the other side. So they're allowed to turn over 2 cards to test the rule. If a card has a vowel on one side, then it has an even number on the other side. Now, the vast majority of people who do this test will pick E and number 4. So they'll pick the vowel to test whether there's an even number on the other side. They'll pick the even number to test whether there's a vowel on the other side. In fact, if you take a conditional sentence like this, like if a card has a vowel on one side, then it has an even number on the other side, then what you've got to test is not simply if it's confirmed, but if it's disconfirmed. And that means that the rational choice here to disconfirm is E and the number 7, because turning over the number 7, if there's a vowel on it, will allow you to disconfirm the hypothesis that if it's vowel on one side, it's an even number on the other side. So it's the difference between confirming an idea and proving it wrong. And most people sort of just go for the sort of confirmation part of the task. And that's sort of how they understand the task. However, this is one of the examples that the sort of heuristics and biases, people will tend to say that this is an example of human reasoning that is not optimal, or that makes these systematic mistakes in how it sort of takes conditionals, like if a card has a vowel on one side, it has an even number on the other, how it takes the disconfirming of those conditionals to work. We saw the conjunction fallacy before when we looked at the dual process theory, and of course it's one of the sort of basic fallacies in the that rationalists have sort of appealed to say that human beings have this kind of systematic bias. So which is more probable? From the description, we learn Linda majored in philosophy, cares about social justice, etc. Is Linda a bank teller, or a bank teller and active in the feminist movement? Now, the conjunction fallacy is just taking two things to be more probable than one thing, which is not possible. So one is always going to be more probable than 2, which is the same condition and something else in addition. But again, it seems that 80% of people, more than 80% in most tests, will go for number 2 as the correct answer. And it suggests that either they're reasoning in a sort of systematically wrong way, or there's something about the question that's kind of producing these false responses. So we'll look at that possibility shortly. Another example of sort of failure to reason correctly is base rate neglect. And again, this is a error that occurs systematically. Base rate neglect is misjudging the probability of an event by neglecting important background information. In the example, there's an example in the textbook where people are misjudging a person being an engineer or a lawyer based on the description of the person and ignoring background information about the percentage of lawyers and doctors in the sample. Now, if you look at this hospitalized with COVID example, it's exactly the same. It looks like there are more vaccinated than unvaccinated people in the hospital with COVID. So you might look at that and say the vaccinated are more likely to be hospitalized than the unvaccinated. But what that doesn't take into account is the underlying base rate. In other words, the vaccinated population is much, much larger than the unvaccinated population. So it's only a small percentage of the vaccinated population, presumably the sickest, the oldest, who are finding their way into hospitals. It's a much bigger percentage of the unvaccinated population. So the hospitalization rate is 5 times higher in the unvaccinated population. But if you just look at the raw numbers of people who are hospitalized with COVID, you'll make the base rate error of failing to take that difference into account. So again, this tends to happen quite systematically. Now, preference reversal is when a preference is put in a different way, but it's the same. In other words, it's just stated differently, but it's asking the same thing. Our preferences shouldn't change. Okay, so what's going on here is there's people are asked to rate two different traffic programs that are expected to cut the number of casualties. 600 people are killed each year in Israel in traffic accidents. So one program would cut the expected number of casualties to 500, and that would cost 55 million. Program Y wouldn't get the number of casualties down to that extent. It would get them to 570, and it would cost 12 million. So the question is, which is the preferred option? And most people go for program X. So most people say the program 500 casualties at the cost of 55 million is worth more than a program that costs 12 million and only sort of gets the number of casualties down to sort of a bit under 600, 570. So in scenario B, they are not told the price of X. So in another version of this, they're not told the price of X, and they're told to state at what price program X would be as attractive as program Y. Now here, 90% of participants provide values smaller than 55 million. And in doing that, they indicate a preference for program Y, even though in this scenario, most people will indicate a preference for program X. But if you ask them to give their value, what price program X would be as attractive, they provide smaller values than 55 million. So again, their preference are being altered by the way in which the statistics or the information is being presented when it's exactly the same information. So we can see another version of this in another, again, a preference reversal example from Tversky and Kahneman. Imagine that the US is preparing for an outbreak of an unusual disease, which is expected to kill 600 people. Two alternate programs to combat the disease have been proposed. Assume that the exact scientific estimate of the consequences of the program are as follows. So group 1 is presented with two options. If program A is adopted, 200 people will be saved. If program B is adopted, there is a 1/3 probability that 600 persons will be saved and a 2/3 probability that nobody will be saved. So program B is about the same, isn't it? It looks like there's a sort of 1/3 and a 2/3 chance. So a 1/3 probability of 600 persons being saved is a total probability of 200 persons being saved. Now in program D, in the options presented to group 2, if program C is adopted, 400 people will die. Note that that's the same as program A. It's just stated in a different way. 400 people dying versus 200 people will be saved. So if program D is adopted, on the other hand, there is a 1/3 probability that nobody will die and a 2/3 probability that 600 persons will die. So here, because of the way that it's framed, and these frames are called the gain frame and the loss frame, program A is stated in the gain frame. 200 people will be saved. Only 22% of people choose option C. The loss frame, which says 400 people will die. So 72% of people choose option A, and again, about over 70% of people choose option D. Okay, but their choices here as we've seen, they're taken by their sort of propensity to take risks to avoid losses, but also to avoid risks to protect gains. So people will sort of will take risks to avoid losses, but avoid risks to protect gains, even when there's no sort of actual difference between those things, but they will act differently in the two cases, because their sense of what it is to take a loss is different from their sense of what it means to protect a gain. So, according to Kahneman and Tversky, these sort of systematic errors in human reasoning are due to the reliance on heuristics. And human reasoning systematically deviates from the rules of logic, probability, and decision making, they're saying. So, heuristics, and this is an example, the representativeness heuristic. It's like a cognitive or a mental shortcut that individuals use to judge the likelihood of an event based on how similar it is to the prototype in their minds. Instead of considering all relevant probabilities, people often evaluate by degree of representativeness or resemblance. This can lead to systematic biases in judgments and decisions. So, assuming a coin toss series of heads, 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 heads is less likely than heads, tails, tails, heads, tails, heads, even though in fact each has an equal probability. So there's an equal probability of both of those sequences happening, but people will assume the latter sequence is in fact more probable. The gambler's fallacy is another example, expecting that a run of blacks on a roulette table makes landing on a red more likely next time due to a perceived return to a representative balance. So we've seen that, the idea that sort of gamblers will keep playing on the expectation that they're going to make their money back when the sort of the system representatively turns and they start making money. But just because you've been losing money doesn't mean that things are going to change and you're going to start winning money, because the probability next time you make the bet is exactly the same as what it was the first time you made it. So often our sort of using heuristics in this way to sort of represent what we expect to happen or the likelihood of an event makes us go wrong in our sort of systematic reasoning. Another example is the availability heuristic. And here we judge the likelihood of an event based on how easily we can recall similar events. So, as opposed to all the information that's available, we make our judgment based on the small piece of information that's recent, covered by the media, or the fact that it's available to us. So there was a bus accident on the news. Riding the bus is dangerous and I'll never ride one again. I've never heard a news story about diabetes as a cause of death. The likelihood of that happening must be low. In fact, of course, that's not true. You're more likely to die from diabetes than a bus accident. But it's about the information we have available. If we see something on the news, if something is salient in our sort of world of information, it's more likely to play a part in our decision making, and we're more likely to recall it because it's available. So this again leads to us making decisions that are sort of not fully rational because of the way we're sort of using this heuristic. All right, so let's have a look at some of the challenges to this idea that people are making these mistakes because they're not systematically rational. And the first argument here is that the results that they are finding, the sort of irrationalities they are digging up, are simply a result of an artifact of the experiment rather than about people's rationality itself. And what that means is that if you kind of restate these problems in a slightly different way, the illusion or the cognitive illusion kind of disappears. Okay, so in the case of Linda, if we state the Linda problem in what's called a frequentist formula, In other words, if you say there are 100 people who fit the description of Linda, how many of them are bank tellers? How many of them are bank tellers and active feminists? The conjunction fallacy drops from about 85 to 20% and even less. Similar results for other kinds of problems. All right, so if you give people a formula where they're trying to calculate the frequency of it, they will get the result more or less correct. So Gigerenzer says this is because asking about the probability of a single non-repetitive event is an ill-formed question, right? So when they ask which is the more probable, that Linda's a bank teller with or a bank teller and an active feminist, that's not a well-formed question, because probability is about the frequency of something happening. So there's no correct answer to it. When it's specified with a reference class, 100 people, how many do this, how many do that, performance improves radically. Gigerenzer also points out that what might be going on with the Linda case is that people are using a conversational heuristic, which says the description of Linda is relevant to finding the answer. And we often assume that information in our environment, if it's been presented to us right there, is relevant to what happens next. And so people are just assuming that the information that they've been provided about Linda is relevant and operating on that basis. So they're using a heuristic, perhaps that works in a lot of cases, but isn't going to work against this this example, which is perhaps an artifact of the experiment rather than sort of testing our actual sort of systematic rational errors. Now, interestingly, we saw the Wasson selection task and how people go wrong with this in just sort of confirming and not disconfirming. But when this test is reframed as a test for a sort of cheater detection test, people do a lot better on the test. So here the rule is, here we've got EK 4 and 7 are replaced with beer, soda, 22 years and 14 years. And the rule is, if you drink alcohol, then you must be over 21 years of age. So here the statement becomes a cheater detection rule. You've got to detect if people are cheating the rule and are drinking when they're underage. So in this case, people are much more likely to turn over the beer card and the 14 years card. Those are the equivalent to the E and the 7, which are the correct answers according to the heuristics and biases people. Defenders of the heuristics and biases program will say that participants don't in fact consider the questions to be meaningless because they answer them. So it's not like those questions are meaningless, they're obviously answering something. But the question is whether they're being kind of misled by the way the question is formed, or whether it's really something wrong with human rationality. So this is the first response is that when you reformulate these questions, a lot of that irrationality disappears. Second response is to focus on this idea of ecological rationality, which Gigerenzer again proposes as an alternative to the sort of logic and probability idea of rationality that Kahneman and Tversky and others use. So the idea of ecological rationality is that humans have evolved to adapt to natural and social environments, and our rationality reflects that. So our rationality is ecological, not logical. It's not meant to adhere to logical rules. It's meant to be successful in the environment in which we are located. So rationality is success in the relevant environment. Now, the frequentist interpretation of Linda, when you put that question in terms of how many out of 100 do this, how many out of 100 do that, it makes sense, because if you think in the sort of the environment that humans have been in for most of their frequency, probability was represented in the frequency format. So people would have talked about 3 rainy days in 10 days rather than a 30% chance of rain. Even today, people struggle with a 30% chance of rain. What does that actually mean? But 3 rainy days in 10 days makes perfect sense. So similar for the Wasson experiment, detecting cheaters has been a very important skill in historical human societies. So when you sort of rephrase the experiment as one that is a sort of cheater detection rule, people do a lot better on it because the sort of ecological nature of their rationality is allowed to sort of express itself. Now, one problem for the ecological rationality view is whether it still holds in the conditions of contemporary, technologically sophisticated society. Are they still relevant when people are often given tasks to decontextualize information, and maybe information about cheaters is not so salient in these environments? So the question is whether the kind of logical parts of rationality, the kind of the things that the heuristics and biases program focuses on, have they become more relevant in a technologically sophisticated society, and particularly where people can be manipulated, perhaps by advertisers, perhaps by political figures, into drawing conclusions that follow from sort of drawing on these biases and sort of exploiting people's failure to be rational in these situations. So one of the replies to Gigerenzer is to say that this may have been true, but it's not so true today, when in fact adherence to the rules of logic is necessary for people to avoid being kind of manipulated and exploited. Let's take a look at the preference reversal objection. So the basic idea of preference reversal is we react differently to when the same thing is presented in different ways, right? So we've got a glass that's half full. So if it's presented as half full, we're going to react differently to that than if it's presented as half empty. Now, in an experiment by Scher and Mackenzie, participants were asked to pour half of a full glass into another identical glass. They are then asked, which is the half empty glass? Okay. Now, at this time, they've got two glasses with the same amount of water in it. When most people are asked this question, they choose the previously full glass. And the reason for this, Gigerenzer says, is that people extract surplus information from the framing of the question. So here it's the history of the situation that one glass used to be full, that people extract to answer the question meaningfully. One glass used to be full, and I poured half of it into the other, so that one's going to be the full glass. So the idea of invariance in preference reversal, in other words, the idea that those choices should be seen as equal, is not able to access this background information about the history. Okay, so it's here humans are kind of, when we do this, we're filling in the context and using that context, using that history to answer the question in a way that's not possible on a purely kind of logical analysis of what's going on. So it looks like, again, humans are kind of using their full kind of ecological rationality to extract information from the environment, which is not seen as relevant on a purely kind of logical way of looking at things. Now, it's interesting to compare these cognitive errors we've been talking about with perceptual illusions. Perceptual illusions, so here it's not, excuse me, here it's not our sort of logic that's being misled, it's our perception. Excuse me, so we can see a very nice example of that, I think, in this example of pop-out dots. It looks like some of these dots are popping out from the screen, and it looks like others of them are concave. They are kind of folded into the kind of screen. So some dots appear concave. They seem to sort of project down into the surface. Others seem to be convex. In other words, they seem to pop out to project upwards from the surface towards the observer. If you turn this upside down, or if you sort of turn your head upside down and look at it, the concave dots will turn into convex ones and vice versa. So you'll see the opposite if you look at this upside down. There are, in fact, no concave and convex dots. So what's actually going on here? Well, our brain, as is often the case, does not have sufficient information to know exactly what is going on. So it uses heuristics to make a good bet. And it makes this bet based on the structure of the environment. Okay? So the brain assumes a three-dimensional world, and it uses the shading on the dots to guess in what direction that world extends. And in doing that, it uses two principles. It uses the idea that light comes from above and that there is only one source of light. Now, why would our brains make the assumption that light comes from above? And why would our brains make the assumption that there is only one source of light? Well, because for most of our history, the sun and marginally the moon were the only source of human light, and they both come from above. Now, to say that these are good errors means that they're the result of employing a highly intelligent kind of betting machine that our brain fills in what it sees to kind of bet on what's really there. If our brain reports only on what it sees, it's going to give us both too little and too much information. Perception has to go beyond what is given to make sense of it. And that's why it gives us too little, and it gives us too much because it's impossible to decide what is relevant and what's not. Our brain has to decide that based on the information it's given. It has to pick out what is relevant and what's sort of relevant for making sense of what it sees. So our brain uses these heuristics. It says light comes from above, and there's only one source of light, so it's using that to sort of interpret the concave and the convex dots, making the convex ones appear to be pop-out dots. Now, so here's the thing. If we accept this idea of good errors in the case of perceptual illusions, why not in the case of cognitive illusions? Right? In other words, they're good errors because that's how our perception works. It makes sense of our experience by going beyond what it sees to kind of fill in the information with an interpretation. So why can't we say the same thing about cognitive illusions? In these cases also, people are going beyond the information given to make sense of it. As we saw with Linda, they're going beyond the information to try to make sense of the information they're given in the answer to the question. So again, here is where people like Gigerenzer would say heuristics, the rationality of heuristics is not logical, it's ecological. It's about how we achieve success in our environment through the assumptions we make that have been sort of programmed into us over time to be successful in these environments. Final thing that the textbook talks about is this idea of tracking truth. And there's the idea that following logical and mathematical rules is perhaps the best way to get to truth. However, opponents often argue that tracking truth is not the most important function of belief. So proponents of ecological rationality might say that the point of beliefs is evolutionary success. And we can see that in the perception example, it sort of making those interpretations, even though there are no sort of pop-out dots on the page, but making interpretations about light in 3 dimensions has proved successful to us in our attempts to make sense of the world. But it's also plausible to say that following logical and mathematical rules leads to evolutionary success because tracking the truth is a successful strategy. Okay, so for week 11, there's no quiz this week. There's a markup assignment, which is an interview with Daniel Kahneman. And the VoiceThread assignment, for the VoiceThread assignment this week, we're working on the essay. We're doing the essay brainstorm, same as we did for essay 1. So we're going to kind of share ideas and sort of thoughts about what to focus on in the paper about moral judgment and moral motivation and empathy. So good luck this week, and as usual, if you need anything, reach out in office hours or you can contact me by email.